All right, so we are going to measure these angles. So let's start off with angle A here. All right, how big is angle A?
55.
All right. So remember we taught this earlier in the year, so always go dot to dot. So the dot on the protractor to the dot or the vertex of the angle, and then line on the protractor to the line on the paper. So we get dot to dot, line to line, like this. And so how big is that angle? And it's an acute angle, so you know it's a small number, so it's between 50 and 60. It's 55 degrees. So angle A is right at 55 degrees. All right, let's measure angle B. So I'm going to go dot to dot, line to line. Now this is an obtuse angle, so I know I'm looking at the bigger numbers. So it's like right between 120 and 130, about 125. All right, now for angle C. How big is angle C? Right at 55 degrees. All right, and now on this last angle,
125.
okay, and it's 125. Now, this that we're looking at today is a parallelogram. We've been talking about polygons in general, but today we're going to kind of focus in on basically four-sided polygons for the rest of this unit. We're just going to talk about quadrilaterals. But this specifically is a parallelogram, and that's what we're going to talk about today. You know it's a parallelogram because both sets of sides are parallel. So these two sides are parallel, and these two sides are parallel. And there's going to be several properties about that, and we're going to kind of just see those in this one parallelogram here. But the first thing I want you to notice is these two angles. What do you notice about these two angles?
They're the same.
They're congruent, and these are what we call opposite angles. Okay, they're not next to each other, they're opposite angles. They're congruent. What do you notice about these two?
They're the same.
These opposite angles are the same or congruent also. And it works that way in every single parallelogram. The opposite angles are always congruent. All right, next thing I want to do is I want to measure the length of the sides in centimeters using a little ruler right here on your protractor. So how long is this side right here? Yep, about 9.2 centimeters. Now let's measure this side up here on the top.
It should be the same, shouldn't it?
Well, let's see. How long is it?
9.2.
It's 9.2. So yes. So this is another property, and we're going to talk about this more specifically in a little bit, but opposite sides like this are always congruent. So these two are the same, and then let's measure this over here. How long is this side? About 6.6, 6.7, somewhere around there. We'll say it's 6.7. And then if I measure this side over here, it's the same thing, 6.7.
Does it equal 360? Since it has four sides? Or?
Okay, good, yes. So if you added up all four angles, if you added that angle, that angle, that angle, and that angle, yes, they would equal 360. All right. So that's kind of the second thing, is that the opposite sides are always congruent. Now, next thing I want you to do. Well, before we do that, what I want you to notice here is what happens when you add 55 and 125? Plug that in your calculator quick. What's 55 plus 125?
180.
It's what?
180.
180, yes. So these angles that are right next to each other, and again, this is not by coincidence, it always works this way in a parallelogram. These angles right here will always add up to 180. 55 plus 125 is 180. All right, now what I want you to do with your protractor is I want you to draw in the two diagonals and try to get it as close as you can. Get it where that diagonal goes right up into the corner there. Now, what I want to do is I want to measure this angle right here. Now, we've already measured the whole angle. The whole angle is 55. We already did that. I want to measure just this angle that we created with this diagonal. All right. So I'm going to put this up here. So there's the 0 right there. Then this red line is the one I'm looking at. Where does it go? Yep. 32 degrees.
So it's not supposed to be the same? Like they're not supposed to be the same?
Well, you're talking about these two?
Yeah.
Not in this case. There will be some of these quadrilaterals we talk about next week that'll be that way, or this week, whatever, but not on this one. Yeah, this one would be different because it would be 55 minus 32 to give you that one. But what I want you to do now is I want to measure this angle right here.
Same thing.
Okay, let's measure it and see. So how big is that angle?
32.
You can see right there, it's 32. Okay? So this is based off something we talked about like last semester, a long time ago. These are alternate interior angles of parallel lines, okay? These two lines are parallel, and so these alternate interior angles will always be congruent. So we're going to see some stuff like that showing up today. Now there's one more thing that I want to do with this, and what I want you to do is on yours, I want you to measure from point B to the very center right there. Measure it in centimeters with your with the ruler on there. Okay, now I'm talking about the length of it. How long is it from here to here? It's what? So it's about 3.8 or so. And then what I want to do is to measure from the center to this point over here. Should be, mine shows 3.8. So yours is really close, but and your other one may be 3.7 also. But so what do you notice about these two pieces right here? They're the same, okay? And if they're not the same, then you probably didn't get these exactly in where they needed to be there. But those two should be exactly the same, okay? And that's going to be the other thing we talked about, is that where these two diagonals cross each other, they cut each other exactly in half. Then if we measured this and if we measured this, those would be the same. So let me just measure that real quick. So that's like nearly exactly 7 centimeters. And then from here to here is nearly exactly 7 centimeters. All right, so we're going to talk about all these properties, and I'll define all those, but I just wanted you to see it with your eyes that this does work. So I'll be referring back to this as we go through the other stuff that we're going to do today.